On Friday, oh, you might also want this guy out in front of you. You might not need it, it's hard to say. So on Friday, we color coded this set of rock layers. So this strata. And we cut it out and we put it back together the way it was before the fault broke everything. When we put this together, it was super easy to identify the oldest layer. How do we find the oldest layer? Right, you look on the bottom. So you can see that the bottom layer is up here on mine, it's an orange layer, it's conglomerate. And then we worked from the oldest up to the youngest. Who remembers what this caterpillar-like thing is called? That's an intrusion. And a quick refresher, how do you know that that's an intrusion and not an extrusion? Hint, do not say because it's inside. It has the contact metamorphism all around it. Now, I just want to say something. If this was a Regents question and they said, how do you know that this is an intrusion? You can't just simply say, because of the contact metamorphism. You need a full thought, not necessarily a complete sentence, but you need all the thoughts you have. So what about the contact metamorphism tells you it's an intrusion? Put that in a full sentence. What about the contact metamorphism? Where is it? There, it touches all the layers, or it's all around it. You can't simply say the contact metamorphism. I need more. So be careful with that. So what we did on Friday then, if you do recall, is we took these layers and we looked at here, and using the key, we put them in order from oldest to youngest. So again, the oldest is on bottom, which when it was put together was kind of difficult to see. So what I had to do was put them, or so when it was like this, it was hard to see. So what I had to do was cut them out, and then you could see that the orange layer was clearly on bottom. Now on the Regents, are you going to be able to color code and cut out and tape them back together? Obviously not. So what you kind of have to do though is do that in your imagination, which I know most of you can. So you would see what layers match up, and basically in your imagination, you'd have to shift them back the way they were to see which one is truly on the bottom. Or another thing, if you can't quite use your imagination, you see that these layers like this go together. So that would put this little section on the very bottom. And so we did that on Friday using the key. But again, remember, if there is no key, you have the symbols on page 7 of your reference table, which we are going to need later on today anyway, so you might want to have those out. So we put them in order from oldest to youngest, putting conglomerate on the bottom, followed by the dashes, which is shale, then the sandstone, siltstone, limestone, breccia, then the intrusion squeezed through. And then how did I know the fault came after the intrusion? Who remembers? Because the fault, so remember this break here is called a fault. We know that came after the intrusion because the intrusion got broken. And then finally, never forget the fact that that's not a beautiful straight line on the top, that's erosion. So on Friday, we got this far. So if you don't have these all filled in, you'll need to fill those in now and know how to do them. I see some people copying, so I'll give you a minute to get that in there. There's a thingy. Those of you who have been in lab already, this is all sounding very familiar. You're probably much better at it today than you were last week. All right, but then the next thing you'll notice is more than half the table is blank. So we only did the very beginning here. Now we need, it's labeled event and environment. I guess I should have probably said of formation. But really what this is asking is the event, meaning how this happened, meaning how these layers get there, and environment, meaning where did this happen? And here's where we're going to have to pull together chapter 3, rocks and minerals, and chapter 5, weathering, erosion, and deposition to get the full answer. And I'll tell you, this is the kind of stuff the Regents loves because they're taking chapter 6, 3, and 5 and putting them all together in one question. Neither one is really that difficult, but you have to combine all three. So if you forget something, you'll end up getting it wrong. So what I'm saying is, we know the order. The first thing that happened is conglomerate was made. But now you need to reach back in the archives and tell me how conglomerate is made. So how do we, first of all, conglomerate is what? It's a rock. So where would you go in your reference table? If you know it's a rock, where do you go? Page 7. So I was going to say 6 and 7 because there's igneous rocks here on the bottom of page 6, sedimentary on the top of page 7, metamorphic on the top of page 8, or no, on the bottom of page 7. So search through those 3 pages and find the word conglomerate, which is on page 7, the top. So it's a sedimentary rock. So we need to know in general, how are sedimentary rocks formed? Where do we go to remind ourselves how they're formed? Page 6, this guy right here. And again, so here's a sedimentary rock. How did I teach you to read this to figure out how they were formed? Read it backwards. Sedimentary rocks are when sediments get deposited, buried, compacted, and cemented together into a sedimentary rock. So that's part of it. The other thing is you got to be a little specific and tell me how conglomerate formed, meaning what specifics do we need to know about conglomerate? So again, what rocks are in it? Specifically, what makes conglomerate different than all the other guys on that page? So go back to conglomerate and read about conglomerate for a second. So what is conglomerate made out of? Pebbles, cobbles, boulders embedded in sand, silt, and clay. Pebbles, cobbles, and boulders, if you don't remember, pebbles, cobbles, and boulders, they're the big sediments. So conglomerate forms when pebbles, cobbles, and boulders get deposited, buried, and compacted together into conglomerate. That's basically what we need to write. That's part of it. So I'll start you up here. Oh, we'll sum that up as saying large sediments. So large sediments get deposited. That's only part of it though. They also want to know the environment, meaning where do large sediments get deposited? Now, if you think back to all of the stuff we learned about deposition, weathering, erosion, and deposition, what's the #1 agent that moves most sediments? I didn't hear, I heard a few mumbles, I didn't get water. Running water is the #1 agent of erosion. So we can pretty much assume the sediments are getting moved by water. Yes, some other things move them, but we'll just say most of them get moved by water. So when sediments are moving by water, when do they get dropped off? In general, when do sediments get dropped off in a river? When a river is moving. When a river meets what? When it loses its strength. And where do rivers typically lose strength? At the bottom of the silt bodies, which is where? Ocean. Typically an ocean or a lake, which is exactly so. Just like a water slide, when it was coming down the slide, when did it lose its power? when it hit at the end of the slope, which is where the pool was. So sediments get deposited in water. Now, here's the kicker you got to remember from last chapter. We have large sediments. Where do the large sediments get deposited? Or when? How about that? When do the large sediments get deposited? First. And that's typically, if you picture a river entering a lake, that's usually where it's the shallowest. So large sediments get deposited in deep, shallow. Because when a river enters a lake, right at the beginning of that is usually shallow water. So conglomerate happens when large sediments get deposited in shallow water. So this is all the info we're going to need for almost all of these. So let's do the same thing for shale. Search your reference table until you find shale. Still a sedimentary rock. So it's still when sediments get deposited, buried, compacted together. Specifically, what kind of sediment is shale?
Clay.
Right. So shale is clay-sized sediment. So instead of just saying large sediment, we're going to say clay sediment. Or clay-sized sediments probably would have been better. Now, clay are how big? Less than 0.0004 centimeters, which is really, really, really tiny. So picture these really, really tiny particles heading down the river, hitting the lake. Where do the teeny tiny particles get dropped off? Where did my little daughter get dropped off after the water slide? Well, yes, she will eventually hit the bottom, but
The top.
okay, so going down the slide, big sediments get dropped off first.
They're at the top of the water.
Yes. Okay. No, guys, we got the river flowing into a lake. Which sediments get dropped off first?
Big ones.
Big ones get dropped off first. Where do the little ones get dropped off? Way, 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 way out here. And if they're the tiniest, they'll get dropped off way out there. You guys remember that? You guys scared me there for a minute. Big sediments get dropped off first, little sediments get dropped off later. This is going to be deep. See how this is shallower? Now this is going to be deeper. So now we say clay sediments get deposited in deep water. We gotta do that for all the different layers. So let's keep going. Sandstones, what kind of rock? Sedimentary, so same deal. Sediments get deposited, buried, compacted together into sedimentary rocks. Sandstone, how big, what kind of sediments are sandstone made out of? Sand sediments. So the sand gets deposited. Now sand, how big is a piece of sand compared to that clay or the pebbles, cobbles, and boulders?
Bigger.
It's bigger than clay, but smaller than pebbles and cobbles and boulders. Sand is basically a medium sized. So it's gonna get dropped off in medium water. Now you could say that, but I'll give you a hint. The regents will never ask you exactly where sand was. The key is that you know the big guys get deposited first in shallow water and the little guys get deposited last in the deep water. All you got to know is that the sand gets deposited in water, plain and simple. No need to overthink those medium guys. So same with siltstone. It's just in the middle We just say it gets deposited in what? Oh, so speaking of, so siltstone's next. Again, siltstone's what kind of rock? And it's made out of? What kind of particle? Yep, so this is silt sized sediments. So silt-sized sediments get deposited, again, silt's in the middle, so you can just say in water. It will only ever ask about the biggest ones and the smallest ones. Would you get to the next one? How about limestone? What kind of rock? Sedimentary again. But this time it's not made out of a sized sediments. What is it made out of? Calcite. Let me show you. Limestone is made out of calcite. Now, how big is calcite? So everybody look, how big is calcite? No, how big is calcite? Microscopic to very coarse. What's that mean? Or? No, that's the microscopic, teeny tiny. But what's very coarse mean? Really big. So basically, calcite can be any size. So what should we say about where it gets deposited? So it's either. So what should we say? Yep. Calcite gets deposited in water. So again, unless it's really big, shallow, really small, deep, if it's anything in between, we just say in water. How about breccia? Sedimentary. How big? So find breccia. Pebbles, cobbles, and boulders. What did we call those before? Just large sediments. Large sediments deposited. And where do large sediments get deposited? First, which is shallow water. All right, let's switch it up here. And an intrusion is made out of what kind of rock? Now it does tell you up here, we forgot to write it, it's basalt. But remember, an intrusion is hot lava. So what kind of rock is hot lava that cools and hardens? Oh man, oh boy. Well, so I appreciate, Jake, thank you for, even though you said some wrong things, thanks for participating. The rest of you, speak up. So when we have melted rock, which is magma that solidifies, it makes an igneous rock. So it's an igneous rock. Again, igneous rocks go from, or they happen from when hot lava cools. Well, let me write that. Lava cools and hardens. And since it's an intrusion, where does this happen? Inside Earth. And a fault. What's the event that would create a fault? Yeah. Tectonic plate movement, I guess is what we'll call it. You can word that however you wanted. Now for the where, you could say inside Earth, but that's good enough. It's just plate tectonic movement. And then finally, the last thing that happened was erosion. since we just finished talking about erosion last chapter, how does erosion happen? Yeah, careful, erosion isn't the breaking. Moving of sediments by water, wind, waves, gravity, or glaciers. All right, we're going to practice some more of these. And when I made this activity, so we're going to page 25, I was all feeling super creative and energetic when I made this activity, and I thought I'd make it a little bit cutesy. And so here's what you got on page 25. Says, you have just completed college with your degree in geology, which is the study of rocks. You've been hired to work with the NCIS unit as a geological specialist. Using your knowledge of earth science, help solve the cases below. So the purpose is to determine the age of rock layers and reconstruct the geological history of the area based on the rocks below the surface. This will help the team determine the relative time of death of a body found in one of the layers. Introduction. The North American continent has undergone major changes in its history. It has been invaded by oceans, racked by mountain formation, and leveled by erosion and scoured by glaciers. Many species of plants and animals have appeared, flourished for a time, and become extinct. A detailed history can be told about our continent, even though most of it occurred far longer ago than anyone can personally remember. Most of what we know today has been a result of a long and careful study of the rock record. The procedure for this activity. The following are generalizations that can be made about any cross-section of rock. So these are 4 things you just got to remember. In undisturbed rock layers, the younger layers are on top and the rock gets older as they are buried deeper. B, igneous intrusions, faults, and folds are younger than the rock layers they disrupt. And C, generally when an area is underwater, deposition takes place, and when it is above water, erosion takes place. All right, number 2, you're going to observe the rock layers on the subsequent pages. Using those 3 assumptions above, determine the order of events, including the deposition of rock layers, faulting, folding, intrusions, etc. And number 3, complete the data table below each diagram. Include the order of events, so the letter or the number, the name in the rock layer, if applicable, and the depositional environment in which you can infer those rock layers were deposited. So again, we're putting them in order, naming them based on the key, and then telling me how they form, just like we did on the other page. So let's give it a whirl. The only thing different here is there's a dead body in each of the layers. I know. So this is just like what we did, except for there's a dead body. Turn the page, there's another. Okay. The other thing I want to say is, as you can see, these symbols were hand drawn. So obviously the bricks, to me, they look like bricks. The dashes are clearly dashes. And if you ask me, what do you think layer 9 and 7? What do they look like to you? Dots. And on the page 7 of your reference table, what are dots? What kind of rock are just dots? Sandstone. To me, this layer here also looked like dots, but it's not as much like dots as that one. We're going to call layer 7 conglomerate. And I will just let you know on the regions, There will be no guessing what the layers are. So they won't be hand drawn. They have better abilities and can like insert the actual pictures right off the reference table. So this one, that's the only thing. I think 9 is and 7 were definitely polka dots, but that number 1 we'll call conglomerate. So we got to put these in order. It tells us oldest to youngest at the bottom. So we're putting oldest at the top here, which be careful. Sometimes like in the lab, they're going to ask for the youngest than the oldest. So always read carefully. Before we get started putting them in order, I like to ask myself, what's messed up here? Because remember, the layers are supposed to be horizontal, principle of original horizontality. So what happened here to make them look like this? Now, what's a fault? Because people always say fault right away. Okay, that's what's happening here, but let's answer my question. What's a fault? A cut or a break. So going back to lab, if you've been there already, this is how a fault's going to be represented. So the layers are going to be broken and shifted around. So it's like somebody took the rock layers, broke them and moved them. That's a fault. So this is more like what we're looking at. What's that? That's a fold, a curve. So think of that as if you had rock layers. So this sheet of paper, these bunches of papers, and I start to fold up these layers. So that's what this is going to look like. So that's going to look like a fold. What's the answers? Yeah, that's just the, sorry, no such luck. So they're folded here. And before, again, I keep going, I ask myself, when did that fold? When did it happen? So again, here's what you have to ask yourself. When did the fold happen? Does a fold happen first, in the middle, or last? Last. Remember, the rocks have to be there to get folded. Now let's start putting them in order. Which is the first one that's labeled that was laid down? That number, right? I think that's a 1 since 7 is definitely up here. So the first thing was this layer, which we already said was conglomerate. I like to put them in order before I start the rest of it, just so I don't have to I don't screw up. So let's just keep going with the numbers first. So after this number 1, what was the next thing? 6. After 6, what's the next thing? And inside of 7, what is there? 2, the body is there. I know. Then after the body got there, what happened? 8. Then 9. There's 2 empty spots and I'm out of rocks. Now what happened first, you think? The folding or the erosion? How do you know the folding, which is X, happened first? The folds got eroded. If it was still flat, all of the top layer would have been eroded, and then it would have got to the second layer. But when it's folded, the top layer and the second layer are way up high, so they're able to be eroded. And so then Y, which is the erosion. So we could label those right here, erosion and folding. And real quick, what kind of rock is 6? Just the dashes. Just dashes there. I don't think it's that. Okay, so here it looks like dashes and dots, but for the most part, I see just dashes. Again, and 3 is also shale, which is just dashes. It's okay to have the same kind of rock. How about 7? Sandstone. Again, this is right off of page 7. How about 2? Oh, that was the body. 2 is the body. 8, which are bricks.
I wrote bricks.
Sorry, that was my fault. We already said 3 was shale and 9 again is polka dots, sandstone. All right, then all we're left with is the environment of formation. And I don't know why I wrote page 25 was your homework. It's the next page, which is the 27. I'm sorry, I just noticed that there was nothing on page 25.
Was it 26 to homework?
No, the next pages
Oh, 31.
and 31. So hopefully we'll get through this 27 real quick right now. We got to do the environment, the event and environment. What did we say? Conglomerate, large sediments. Yeah. What about shale? Clay. Where does clay get deposited? Sandstone, what is it? Sand. Deposited. Where? Okay, so sand, because it's in between, we don't know if it's large or small. This is water. The body, you can just say depth. I don't care, or whatever. You can leave it blank. How about limestone? Right off of page 7, calcite. Shale, we already did that one. Clay. I'm just gonna skip some in deep. Sandstone, again, we already did that. That's sand in water. What can we say for folding? How does that happen? Yeah, that's all it is plate tectonics. Movement of sediments for erosion. If we've got 5 minutes, I think we at least can start page 27. Oops, sorry, there's page 26. Oh, what's messed up here? They're not folded this time. They're not nice and straight. These ones are tilted, and it does tell you. When did the tilting happen? So who's tilted, who's not, is kind of what you got to look at. The bottom half is tilted. So let's go. Let's start with the first thing that must have happened. Oh, by the way, when does the tilting happen? After the rocks that get tilted. So the ones that are tilted, were there, and then it tilted. But are they all tilted? No, so it's not the very last thing that happened. All right, so let's start with the first thing that happened. 4, then 5, then 1, then 2, then 3, 6, then what? Then it got tilted, which is labeled Z in this case. What do you notice after they were tilted?
I forget what it's called.
Oh, we forget what it's called. Not a fault. A fault is where they're broken in half. Not a fold. This wavy line that represents erosion when it gets buried. Oh, I love it. I don't remember off the top of my head, so I'm looking at page 22. Or maybe it's 21. I think it was 21, where we wrote in stuff. 22. near the bottom. Unconformity. So this is Y, which is erosion happened, but it's officially an unconformity, which is a buried erosional surface. Then what happened after it got eroded? 7, and what happened in 7? Body. Then 8. Then 9. Then erosion, which in this case is X. Now, is that an unconformity? It's just erosion because it didn't get buried. That's the correct order. You want to do the rock names together? 4 is dashes. Shale. Again, you don't have to memorize this. 5 is that one on the last one we called conglomerate. 1 is bricks. Limestone. 2 is polka dots. 3 is dashes, which is shale. 6 is bricks, so limestone. Z is tilting. What? So that's just tilt. Y was erosion, so it's an unconformity. 7 is polka dots. 1 is the body. 8 is dashes. 9 is bricks. And X was erosion. So you got to do the environment of formation for this page. So again, your homework is to finish page 27 and then skip to 31. You're only doing the questions, not the lines on the bottom. Basically, the lines on the bottom were to do what we just did, but there's not enough room. It will all be posted on Teams. If you ever miss a class, make sure you check out Teams. I list the video and the homework.